Good afternoon, everyone. I am Qian Zhao, a PhD student studying in the University of Auckland. Today, I will talk about my project mapping marine ecosystems of the world. Our project aims to map global ocean biogeography by clustering analysis of environmental data. For mapping and data processing, GIS can help to extract the raw environmental data from the original data layers for data processing, and subsequently visualize the clustered classifications as ecosystems on a map for global marine ecosystem mapping. Okay. We classified the marine ecosystems using 21 environmental variables, including physical, biochemical, and nutrient factors, which were collected from global marine environment data sets. Before the clustering analysis, we normalized these raw data via the standard score method and using principal components analysis for dimension reduction and correlation exclusion. And then we performed the k-means clustering analysis, which is a classic and appropriate clustering method to classify marine ecosystems affected by numerous variables. In detail, the cosine similarity was used as a distance function because it works much better than the Euclidean distance under a high dimension situation. Since each variable is a dimension in the analysis, and there were also numerous variables even after the dimension reduction by PCA. After the clustering analysis, the silhouette values was used to evaluate the validity of the clustering results and to further refine the boundaries between the classifications. The correlations, quantified relationships, and gradient analysis of variables were also performed to seek significant distinctiveness located at the edge of ecosystems. Up to now, we have got different versions of marine ecosystem maps by varying the combination of variables and the numbers of clusters during the analysis. We initially obtained a general classification of global marine ecosystems, as the poster shows, and found several interesting phenomena within these results, such as the comparative similarity between the Black Sea and the Arctic Ocean, shown in our 21 variables with 7 clusters map. The box plots of each cluster and specific water regions in different versions of ecosystems classification were also generated to compare and explore the reasons for their constitution and distribution. Based on the mapped marine ecosystems, the unique environmental characteristic of each ecosystem can be mined and defined via analyzing the environmental variables of the cells belonging to each cluster. And then the map shows both the distribution and characteristic of each ecosystem. And this can be used for a more comprehensive marine ecosystem assessment. For the marine protected areas planning, ArcGIS can use to overlay the current MPA coverage on the clustered ecosystems to analyze the coverage and the function of current MPAs of the current MPAs in each ecosystem, and then it could judge the representativeness of the current MPA networks and where more MPAs are needed. And in the era of climate change, the battery analysis of the future climate change scenario data layers using the same data processing method, we can we can explore and compare how each marine ecosystem would vary with the future climate change, including the variation of boundaries and characteristics. Thank you for listening.